wavelength and frequency are inversely proportional. What does it mean to say it's inversely proportional? That's right. One increases, the other decreases. Everybody's okay with that, right? So, how do we calculate frequency of a wave? What's the formula to calculate frequency of a wave? Can you tell me, Alexis?
Velocity equals frequency times the little.
Velocity equals frequency wavelength. All right. So, what are they asking me to find here? Asking me to find frequency, so I'm looking for which letter? Okay. So that means I got to have V and wavelength. So if I cruise back, I don't want to hear from Bree or Alize because they've already answered. All right. So what is one of these numbers? Somebody tell me something I know. Somebody who doesn't typically answer me. Let me answer that way. Yes, you can. Tell me one of those two numbers. Is it a velocity or a wavelength? Give me one of them.
15 meters is a wavelength.
All right, 15 meters is a wavelength. See how it says distance of 15 meters? That is wavelength. Everybody okay with that? Length is a distance. So that means I'm putting it in for which one? The V or the lambda? So we're going to put the 15 there. All right. The 35 is the what? That's the velocity. So I'm going to put it in for the V. All right. So how do I solve that? I do what? I divide on both sides by what number, Alexis?
15.
Divide by 15 on both sides. Divide there. Divide there. So F equals, what do I get when I do that? 2.3. What unit is frequency? HZ. Everybody okay with that? All right. Number 4. All right. I want you to calculate frequency and period. Okay. So how do I find frequency? Mr. Hernandez, you remember? How do I find frequency? What do I do to find the frequency of the wave? Okay, so how many waves do I have? 1, 2, 3, 4, 5, 6, 7. Everybody okay with John 7? Okay, over. What's my time, right? 1. So 7 over 1 is 7 hertz. All right. How do I do period? Caleb, you remember how to do period? How about you, Nathaniel? Remember how to do the period?
7 over 1.
Anybody remember the formula for period? All right. It's 1 over the frequency. Okay. The formula is 1 over frequency. If I have to do that on that assignment, I'm going to collect. Okay. It's 1 over the frequency. So you got to find the frequency first. So we found, the frequency to be what? 7. So we're going to say 1 over what? So 1 over 7. So take your calculator. What's 1 divided by 7? Point what? 0.142. And what unit did we put on it? Seconds. All right. Questions about that? All right. I've got your wave things graded from Friday. So let me hand those back. Here. 3.
What day did you say you said?
I'll be here Tuesday and Wednesday this week.
No.
Next week we'll be here Tuesday, Wednesday, and Thursday.
That's not true.
Okay. Now, while I'm talking about makeup work, if you have any missing electricity labs or magnet labs, stuff that went with the static electricity, building circuit, sorry, dear.
You good?
Yeah, I just kicked his foot. Circuit labs, static electricity labs, magnet labs, any of those kind of labs, if they're not made up next week, we're not making those up. So you got 2 days this week, 3 days next week. Tuesday and Wednesday this week, Tuesday, Wednesday, Thursday next week. But I want to put all that crap up. Also that old heat lab, the one with the Epsom salt and the yeast. If you need to make those things up, you need to get those made up. Okay? But after this week, we'll be done with really all the physics labs. We'll be ready to test by Monday. So if you need that stuff made up, I may even throw in the wave labs by next Thursday. If you don't have those things made up by next Thursday, you're not going to get them made up. All right? Because I want to be able to put all this physics crap away. So come get that stuff made up. Yes, you were. Do not make that mistake. See what you did wrong with it, right? Right. I don't know if you just did it in your head, didn't use a calculator or what. It worked. Thank you. And I'm going to go ahead and hand back openings, because honestly, I don't think anybody's going to give you any openings. Well, I don't really need to worry about it. See you. It's not here. Now, if you've got any missing work, check out your power school, see what you got missing, get it made up. People who are absent today are missing 2 grades. All right?
Do you know what?
I only know if I look in power school, but if you come after school and make them up, I'll be glad to look at power school and check. It doesn't take long for me to go in there and do that.
I think it's the after school today.
That's fine. I'll be here tomorrow. I'll be here 3 days next week. All right? All right. Find the handouts that we did yesterday. We need to go over some things and make sure you have the right information. We also need to review so that you know what you're doing today on the lab. Rory was not here yesterday. All right? I exempted this. It does not hurt or help your grade that you still need the information. Is there anybody else? Sacramento was not here yesterday. I exempted that, so it does not hurt or help you, but you still need the information. I think that was it. All right, find what you did yesterday, please. Those of you who don't have any information, you need to get the information. Like I just told Roy in Sacramento. It didn't hurt or help their grade because they were absent, so they don't have to do it, but they're still responsible for the information. Now, one side of the paper that we did yesterday, we're going to use during today's lab. One side of the paper that you did yesterday, we're going to use in our wave interaction lab that we'll do Thursday. Okay? So, you will use both sides of the piece of paper. They just won't all be today. All right, so we talked about 3 kinds of waves yesterday. All right, one side of the piece of paper looked at mechanical, electromagnetic, and surface waves. So you need to be on the side of the paper that has 3 types of waves. So are we all there? Yep. Now, in a mechanical wave, all right, you may not have the exact same definition I have. That's okay. Now, if you were smart and you looked at the one that says scavenger hunt and it didn't have a number behind it, there was a video. Anybody use video? Nobody did in this class. Over half the 4th period did. Okay? He just muted my voice. You know why they watched that one? They were done with the notes in 20 minutes. Because you know why? They were my notes. It went along and filled in every chart, every block in that chart. I don't know why y'all didn't, but they did. All right? So, where does the wave get produced from? A vibration. Now, I picked some examples that I liked. You don't have to have my examples. All right? First of all, does the mechanical wave have to have a medium? Yes. And I will review this. Why are you putting that on your head? No, the skirt doesn't want those things on your head. Take that thing off. before she comes in here, or one of her designees is going to here and have a stroke and go, well, why you got her? And then they jump, because I promise you, if they come in here, I will not save you. I will throw you under the bus and save me. Okay? I'm just going to be honest. Now, does a mechanical wave need a medium?
Yes.
Yes, it does. So in the lab on Thursday, one of the things that's going to drive you guys crazy is you're going to have to figure out, is the wave mechanical, electromagnetic, or surface wave? And I'm going to ask you, did it need a medium? Did it have to have a solid, liquid, or gas to travel through? And some of you are still going to stare at me and go, well, did it have to have water to travel through? If you answer yes, it had to have water to travel through, it's a what kind of wave? It's mechanical, because the wave couldn't have moved if you didn't have water for it to travel. Okay, that's a medium. It had to have a medium to travel through. Now, some things that I put are like sound waves. Sound waves are mechanical waves. If you put your fingers here and you feel your voice box move or your throat move or a vibration, that's a mechanical wave. Any of you who played with slinkies when you were little, that's a mechanical wave. You're going to have to play with a slinky a little bit. I really appreciate it if you don't stretch my slinkies too hard. Okay? Any of y'all played jump rope when you were young? That's a mechanical wave. Any of you ever go to a stadium or some of your friends stand up and sit down and people go up and down and create a wave in a stadium? Anybody ever do that?
I did.
You ever watch it done?
I've done it.
Okay, that's a mechanical wave. The people are the medium. When people stand and sit down, that their bodies are the medium, okay? Exactly. When they do that, that is the wave, okay? Now, if you jump in a swimming pool, the waves go up and down in the swimming pool. That's a mechanical wave. Without the water, there's no wave. Those are mechanical waves. Now, the second one y'all wrote down, though, was an electromagnetic wave. It is also produced by vibration, but these are of charged particles. Now, it does not require a medium. What kind of things are we talking about here when I say electromagnetic waves? These are things we can't see. Now, visible light is the only one we can see. Light from these light bulbs and sunlight we can see. Have y'all ever had x-rays? I have. Told y'all my story from the summer. I fell and broke my wrist. I had x-rays. I had MRI on my back. I have a pinched nerve. All right? Those, can I see? Could I see the x-rays when they did my wrist?
No.
No. But did they take x-rays?
Yeah.
Yes. Somebody was able to see I had a broken wrist. They called me on the phone and said, go back to the emergency room. You might need surgery today. Okay? Somebody was able to see I had a broken wrist, but I certainly didn't see anything when they did it. All right? Microwaves. Any of y'all got microwaves? I do. I don't have it written up there, but a microwave, you can't afford one. All right? A microwave could be written up there too. That fits under electromagnetic waves. All right? Infrared, ultraviolet, UV. All of us stupid white people who like to lay out on the beach on the summertime, try to get some tan. All right? What does UV rays cause?
Sunburn.
Yes, and what else is bad for us?
Cancer.
Skin cancer, okay? We can't tell which UV rays cause skin cancer and which don't. It's not like we're standing out on the beach dodging the rays, trying to make sure we don't get skin cancer out there. We just lay and baste ourselves. Can you believe once upon a time, now hopefully people don't still do this, we used to slather ourselves in oil trying to get a suntan. People would lay on the roof and slather themselves in oil trying to get brown. Imagine that. Stupid people. All right, now, surface waves. This is the one that's hardest for people on Thursday. All right? Now, the thing that I tell people to look for, this definition on Thursday, is you're looking for circular motion, and you need two different mediums. So, if you don't have two different mediums, and you don't have circular motion on Thursday, are you going to have a surface wave? No. Okay? So this one, I don't think is all that hard to find if you don't have those two pieces. You got to have two different mediums, and you have to have circular motion. If a tornado is taking place on the ground, possibly. A water spout would certainly fit that. Yes. If it was water spout on the water. Yes. All right. So like ocean waves, because you're going to have water and air. Anything that's water and air is going to be a surface wave.
Like we can let the water out the tub and the
Yes.
rain.
Yes. That would be a surface wave. Earthquakes, where you have ground and air. That's why I said the tornado on the ground. Yes, I would certainly say that could be a surface wave. Thinking about it that way, yes. All right, but surface waves have to have a medium because you got to have two different mediums. And they're again produced by vibration. So does everybody have those pieces on their sheet from yesterday? Particularly the people who turned in blank sheets or had nothing written down. Now, those are the pieces you're going to need for Thursday. Now, you can't lose this by Thursday. All right, we're talking about the two types we're going to do today. All right, so today you're going to use a slinky. And you're going to compare transverse and compression waves. Now, a transverse wave is a wave that moves perpendicular to the direction of the wave. Now, I'm going to go grab my big spray. All right, William and Jacob, since y'all are always wanting to demonstrate.
I feel like there's going to be on a trampoline.
Yeah, it does.
Oh, gee.
When you're on each end of my spring, stretch it out a little bit. And just put it on the floor. I don't want you to hurt anybody. Now, I want you to move it both ways. I need it to be a little stronger than that. There we go. Now, which way is the slinky moving? Which direction is it going? It's going what, John? All right, it's going towards Chase and towards John. It's going this direction, right? It's going back and forth this way. Everybody okay with that?
Yep.
This. Now, it's not only going this direction. What other direction is it traveling? It's going, all right, stop for a second. All right, it's going this direction. You can see the waves going this direction up and down, right? They're also going which way? They're also traveling this direction. Okay, so do it again. All right, you see them going up and down? Going from Chase towards Ana Lucia. Back and forth from Chase to Ana Lucia, and then they're going which direction also? From William down to Jacob. When he gets down there, it comes back. Back and forth. Okay? I stop for a second. Now, if it goes this way and it goes this way, what is this and that in math class? What do you call that direction in math class? Yes, but what is that angle called? The parallel or perpendicular? What is that in math class? Parallel or perpendicular? It's perpendicular, isn't it? Because what angle did I make? I realize I'm not all that straight these days, but is it 90 or is it? It's a 90-degree angle, isn't it? Okay, there's a spring there. All right. So, a transverse wave is that. Okay, so on your papers, did you draw a wave that looks like that? Now, I drew green arrows on mine to show you what I was trying to illustrate. The wave goes this direction, it moves this way, and it moves this way. Okay, so it's moving at a 90-degree angle. Does that make sense to anybody besides me? Okay, so every wave that we drew a picture of on Tuesday, those waves I handed back to you, every single one of those is what kind of wave? Transverse. Every one we labeled amplitude on. We labeled a crest. We labeled a trough. We labeled the wavelength on. They're transverse waves. Now, examples of transverse waves that you might have written down. I wrote down X-rays, light, electromagnetic waves, stadium waves, any of those. You could have others. Those are just ones I wrote down. Now, does it need a medium? No. Transverse does not need a medium. Now, you can have different examples than I have. Those are just ones I wrote. You do not have to have the same examples. Now, how is this different from a compression or longitudinal wave? Now, the second kind of wave we're going to do today in the lab is a compression wave. Now, a compression wave has a second name. It's also called a longitudinal wave. And I will use both names so you get used to seeing both names. I will use them interchangeably between now and test day. Compression and longitudinal. All right? It's a wave that moves parallel to the direction of the wave. Now, notice that this is my picture of the wave. Is there any up and down movement this time? No. Can I label a crest or a trough? No. Can I label an amplitude? No. Now, with my slinky, I might draw it. That way. Now, I don't know if you wrote this down, but if you didn't, you need to add it to your paper. See these two words right here? These are the two parts of the longitudinal or compression wave, and you need to have them. Now, a compression and a rarefaction. I'm trying to point these out in my wave that I drew here. The compression is there in this one, and the rarefaction is there in the slinky.
So it's like the compression just goes together.
That's right. The compression is what? I'm trying to show you the compression is here. What happens there in the wave? The dots are what? Close together. I probably put that here. I did. The two parts of a compression or longitudinal wave. And a compression is the area where the wave is pushed together. All right? Yeah. Yeah? You gonna die?
Yeah.
You got any all passes left?
No, I'm about to say. You got third, don't you?
I got lunch with you.
Right. We got third lunch.
Yeah.
We gonna eat in here though, because it's cold outside. We're not gonna be whatever it is. Course.
All right, so it's an area where a wave is pushed together. So what's a rarefaction then? Where they're spread apart. Okay, so it's an area where the waves are spread apart. Okay, so where they're spread apart is the rarefaction, and where they're pushed together is the compression. Now, when you're doing the lab today, you have to draw. I'm just telling you up front. You have to draw. So if you draw me a longitudinal or compression wave, you have to draw these two parts. So when you draw me this wave, if I can't tell where the compression is or where the rarefaction is, do you get credit for that wave?
No.
No. Now, I am not an art student, not a good art person. Y'all know this. Been together over 12 weeks, well, about 12 weeks now. So, If I go back for a second, my slinky's not all that hot, is it? It's just some loops. Can you tell where the areas of my slinky got close together and where the areas of my slinky got spread apart? Okay? You should. You should be able to look here and see that right here, my slinky did what? It compressed. The loops got closer. What happened right here? They spread apart. What happened right here? What happened right here? Okay. You should be able to do that when you draw your slinky on the paper. Now, if you want to draw a slinky that is longitudinal, see how it's in a straight line and flat? That's longitudinal. Now, if you want a slinky that's transverse, your slinky needs to do what? Up and down. Now, I'm not a good art teacher, but even I can draw a slinky that does this. Okay? Can you tell that that's transverse and it goes up and down? Even I can. It doesn't look all that stellar. I'm not looking for artwork that, is going to get me a prize. But I need to be able to tell transverse and longitudinal. You see the difference? Okay, because that's what I'm looking for in your lab. Can you tell the difference between transverse and longitudinal? Can you tell the difference between a compression and a rarefaction? Everybody with me on that? All right, so you have to have a medium, and those were just some examples that I put down. Questions? Everybody got their notes sufficiently taken care of from yesterday? Yes? All right, let's talk loud. How many people do I have here today? Let's count the people.
16.
Do I have 16? All right, so we got 8 groups of 2.
You already know about that.
Now, on the front side of the lab, there are 4 drawings that have to be done. And then on the back, there are 6 questions that have to be answered. This lab should take us about 25 minutes. For tonight. You grab the slinkies out of the cabinet, and then y'all will be ready to go. Before somebody falls and injures themselves. Now, I would ask that you not stretch my slinkies so far that you leave 3, 4, 5, 6, 7. For example, notice they're in bags. See how when I set this one down, it has some little glitches where it doesn't quite lay flat. That's where people stretch him too far. I like this one's a little worse. And it doesn't quite sit flat. 1, 2, 3, 4, 5, 6, 7. I think one more. 8. Great. All right, there's 8 slinkies. So, get a slinky. Do it on the lab counter. Don't let them hang off. That's usually what messes them up. And it's what, 12:20? You should have this done by 12:45.
Hey, because I was looking because I feel like the Nora from far back to say. And I was like, oh, I thought you was the Nora. He was like, what grade are you in? I was like, he was like, y'all like, I thought you was like, it's so cold.
What about?
I'm tired. I just want to, I just never jiggle right because I don't think that should be smart. That's sort of real quick, Anna. When you get it. I knew that. I was like, when you get it. How much was it? How far is not far, but
You're doing more about wiggling it in directions, not about stretching.
what which one is the
It's telling you, one of you can stretch out, one of you move it one direction. Yeah, but it says,
We
and we got to stretch it until there we go.
all right, move your end of the spring and return it. So one of you is gonna hold it, one of you is gonna move it one direction to the other. Back and forth. And then you're gonna draw what it looks like.
And then
How far do you? Just to.
good. Check yours. One person, you go, one person.
Yeah, only one person.
Oh my God, guys. I am so mad. You can do this easily. Observe the direction in which the pulse. Well, once you see the pulse, like maybe draw it. And the direction in which the coils of the spring. Make a sketch of the pulse.
Oh, they're going back to what kind of way?
Hold on. You move yours like that. You go, I'll go back. No, you go, I'll
Right
go
here.
back, and you gonna go
On the,
up.
do we draw both lines?
Like this, you gonna go like this.
No.
Go like.
Because that one you're just having somebody hold it, and then you're moving it back and forth.
Yeah.
What you do when you do that?
We got something practice on there. Okay, you go up. No, you go up like this, and I'm gonna go down like this.
Hey, how old are you?
That's what you made in that first one to draw.
What is
And
it?
then you want to-
Like, the first part.
I can't explain how it looks. It look like, but you don't move it. Like, now we got.
You're drawing that. That's what you're doing in step two. Now draw what it looks like.
That's not
The blurry.
Which one of those two pictures at the bottom of this?
Like that.
Draw that over.
Oh, that's why I didn't have to come down on me. She was confused. I was trying to explain.
That's what it wants you to do. It wants you to draw that way.
But then,
You don't answer the questions before you
It's
do
hard to draw
the
those
What?
Damn, this hard. I'm gonna draw a little circle.
Get back to me.
I'm gonna bring my lawyer. They had a big ass transfer.
Michael's jealous because we don't want to
I want to go to multiple.
You know, Michael sent me a. I said, ew. So I might want to hear that back up.
We're gonna go on my, out of our house, put them in our yard.
Trying to fight me.
Let's get moving back. Take it over the show and I go that.
Yeah, how mine's look? It looks nice. Thank you.
Oh yeah, one time that they had literally in the street. And I went like this, and the back ripped, so I went out line. There was the lady driving, she was going slow, her window was down. She pulled over, and I was like, oh. So I was gone, like the windows.
Richard, short distance. Down the street. Reach a short distance down the screen and gather the coordinates quickly release them again. You just pull one, wait till you pull one side. Then let it go. Yes, that's what you're saying.
Man, I love all those.
Oh, well, I mean, like,
I wasn't.
probably
gonna do
another
that.
business.
They're talking about this, like this, or they talking about like this.
I got me.
Yeah, he's talking about like this.
They had like
Practice maybe needed.
discount on their laptops.
Oh,
It
no,
was
like
one
that.
of, I wanted to get it, like 800.
They're talking about like
Discount on
this.
1600.
Just no idea.
I don't know, something about the TV.
Which wall? Coils of the screen.
What the number 3 mean?
Shit to watch on it anyway.
Yeah, it said, reach a short distance.
And here.
My brother paid half of it.
So you're gonna gather some together.
Okay.
And then you're gonna let it go.
Well, we're about to do it.
Oh, okay.
So if you-
Wow, okay. Absorb the.
No problem.
Look at
Yeah.
you.
No, no, I went to that. That's where I got this. I got
It looks like that.
Okay? Y'all can keep practicing.
I can't draw how this looks.
They put the price up on everything, they put it up and down.
You wanna do it? Do it, man. I guess it's fun. You gotta do it live. Hold on, let go, hold on. This again. Don't let it go. Say like this. Yeah, like this. Take a light. You let some
We just drop it down.
That's what I'm thinking.
You can bring it tomorrow. I can wear it. Huh? I mean, you can bring, it doesn't lose its value, so. If you ever want to sell it, people are gonna pay that.
Like this. Yeah, from dry out. It's not really moving at all.
Oh, that's what we're just doing. We gotta do it a bit.
Oh,
That's all.
I hear those stupid fucks. You know what he said? Like last month, it's like,
have your partners.
we were arguing about this, like,
Have your partners then sideways closest to you at the same time as you put the sideways closest in the same direction. Carefully observe the force and they come together. And after they pass through one side, this is fun. This shit fun as hell. I ain't never really had something like that. Just I pull it out. She might like it this way.
So we go for it.
You know, send the sideways post to me. No, just one. Like, oh,
What was it, just one?
it says, so it's the same partner sends sideways posts. Oh, yeah, posting so yes, one to you at the same time. You produce sideways. So we doing the same thing we were doing.
But we gotta do it the same way, right? Oh, you wanna go this way?
And it comes with like 16.
I make sure my hand like this.
This wide.
Nice. It's like, my pussy
But I got it. My turkey is this way. They still rub.
Mars would be like,
They still hit the.
no, we're not going to.
Too big.
Oh, yeah, she was like,
It look more like this. Yeah. It's not doing like
up and down.
it's like the same place. So it'll like,
Do we got to describe and draw?
No, you have to draw.
I wonder, like, whenever.
and like that. It's like it was starting from.
Like that, it was just
I
too
don't
bad.
think it's this. We already know what that looks like.
They spend so, not that, but they spend so much money in the front, like, they're going back. The same like, that's it. Pass them, it's all tips out,
Maybe
like
we're going
that.
in the same direction. No, let's do it in the same direction.
We're going that one, we're going that way.
We gotta do it in the same direction, then we gotta do it opposite direction.
It was all black. It's like back,
Alright, just.
like that.
No,
You just go for
so
it.
which way you going? This way. This way? Alright, no. You go this way.
Okay.
Yeah.
Oh, that's really good.
Good time.
That's what we're gonna do.
Okay.
Just make stack on my desk.
No one?
Throw it on the corner.
There's some problem. There's some problem.
Yeah, one. And once
What's
they
number
hit
one?
curve. Why don't you give it a W? Come on, son.
This one you show.
They said 5 years ago, you would get $500 for free.
What kind of way can we use that? 30. What the hell is that? That's
Yeah, it was.
also the same opposite direction.
Yeah, it's like.
So at least he sees that you can put money in the more.
How could you show it? Energy is showing up online. Oh, that's a hard question a little bit.
Hey, Sam.
What kind of?
It's like, like all the apartments are, all of it goes together, like, you have no land.
Two with the.
Say what?
Yeah, everybody else stuck on three.
What, the answer to the question?
Yeah, it says like what kind of way. Step two.
Our students, so like $13.
I need to know what three is.
Question 3 is asking you what kind of way can you tell the energy move, right? That's the right
How can you
question,
show the
man.
energy is transferred from one end?
I'll take almost anything that makes sense.
One half is like
Just walk.
why not do my half?
Movement.
Back is more than 13.
Who we do vibrations too? Who do vibrations?
I told you, I'll take almost anything that makes sense.
Or you can afford it. You can add it to you.
I'll take almost anything that makes sense.
Well, I wonder what he got. I wonder if he got a new legend.
Or do you want on that?
I'm gonna put the new for my hands called vibrations. How you say yours? Yeah, how you say yours?
I said, you can tell that if you be
That's what I have to think. I don't even know. Yeah, I had to think too.
Feel me now, yeah.
I'm walking.
this one.
I think he has to come in.
Oh,
He
that's
took the
the
thing out, he gave me the key. He's like, here, you go. Well, he drove me there, then he was like, here. You know, you back for you like 8 hours.
What's the size of the resort?
It was gone.
Big ass.
Fucking his side chick.
Big ass.
His wife, he let his wife out.
Ain't that it? This is the best I got. Good shit. Yeah, it's just one big ass. What did he accomplish? And I say close, should I say, I'm gonna say close, right now, I'm not gonna put weight on. What is the size of the post made? Oh, well, that's not saying to the organ, that's saying. No, yeah, it wouldn't be that.
No, this is the same.
Which one?
When I hit it,
No, number
Oh! You're right.
Well, that's the same.
He's like, I'm gonna put them on, but I'm not gonna tire them. I'm not gonna be able to use them. But he just put the others on, but not the tires.
I told you it takes you
So, it's supposed to be like constant.
You guys have about 4 minutes.
So the pulses are.
12:40.
I'm gonna put the pulses in different and constant.
What kind of way? Step through and all of I don't know how to say that word. No, it was this one.
Right.
Remind me of that one on the world record. We were playing like that book.
Oh, we can
Where
use
the
it.
head down. You know, I'm talking about that.
If it's together.
She like, yeah, she had the twin. She the broken. She's a single one. Yeah.
This was stressful.
Me and my little brother.
When two right legs go in the same direction, each.
The poses aren't really different. They're the same. They look the same. They just not what you put.
That's why.
You can access, right?
Yeah.
He was studying something.
I don't know if I write some. Have to delete it. I mean, I said delete it. I think you erased it. Ooh, I want to don't judge. So it's not. Now you even come to some of it. Oh,
She's looking.
Yeah, it goes like that and that.
So look at.
you got 2 more minutes. Smaller. That's smaller. You will look at the middle there.
When they say 2 sides, what do you mean by like,
How do you
it said like 3, I mean before it said.
I'm looking to make it bigger and come on.
all right, so
So we put big and small.
They just smaller.
So when weights come together, just make it bigger or smaller. That's what we're looking at.
We did it again? No.
I don't know. It's asking you. If they get bigger or if they get smaller.
you got compression on it. Unless y'all got it on active. Oh, compression. Ain't that's mine too.
Yeah, it was.
She just wanted to talk to somebody.
So those are the biggest and the smallest. Oh, yeah. One of those. I mean, Mama was in D-Day.
I said, I ain't got nothing. Up your ass.
But it's because of the
What do you think?
This is the same one, isn't it? What's number 5? Isn't it the same?
Bigger or smaller, or you gotta explain.
But it's opposite direction. I'm a good one. What difference is different? No, they move in the same direction and they push with
Is that still what is trans? How do, whatever it is transfer waves.
they move in the same direction and push together.
All right, I have time. So I need papers to be moving my direction.
It's a one big post.
That's what I did trade.
But it's bigger to get smaller. If you will, make sure your slinky is back in the little bag. Set it on the back table. Then make sure your lab sheet is on my desk.
What's the thing you look?
Put his foot on the wall. Oh, you
It was just on.
I need lab sheets. Those of you at the back, let's go. I don't have time for you to sit and socialize and then not finish. Put your slinkies in the bag over there on the counter.
Did you grade?
Yep. Yes, upgraded for right wrong answer. Yeah, that's it. I said, principally, it'd be Wednesday and Thursday. I don't know.
Yeah, we have work to do with the there.
Very simple. Put it on my desk. Ooh. You back up there. Make sure I have a lab sheet review on my desk.
They already took them on the thing.
Patty, put Slinky over there. Then move back where you belong. There's your sheet. 1, 2, 3, 4, 5, 6, 7. This one. Put it up against. The lab sheet's left over there, not turned in. Now, the paper I just handed you is a grade. I'm collecting it. I'm grading it for right and wrong answers. You may use your notes. Okay? You may use your notes. Let's mix the lab. You may do that. So it's going to let you have to back up. All right? So, you took your notes while we were labeling. You've done your waves. You've got those. You've got your notes that we went over from yesterday. You may use any and all of that should you have forgotten something and need to look it up. There is a front and back side to that assignment. Don't just rush to the front and hand it to me. There's two sides. All right? Some of it does have some math, so you may want to calculate it. So be sure to answer all of the questions. If you were paying attention yesterday, a lot of them are very similar to what we did yesterday for review. Caleb, bring your phone up here, put it on my desk. What's wrong? Okay, remember, you can't talk, so if you need something, that's me.
Do I have to spell it out or can I use a abbreviation?
For what?
For like wavelength?
Sure, you spell that out. What are you gonna write, WL?
Yes.
No. Don't write it on the quiz letter this week either. Hmm? I think last time I just had them draw it on. Let me look at it, rather than actually. Instead of in number 17, it asks you to actually measure the wavelength. Look at number 17. Instead of measuring it, use your pen or pencil and actually draw it on the wave, okay?
So just show you what.
Yep, just show me what one is. And I know I don't hear y'all up here talking to me. Oh, what you need here?
You want to just stop saying, hey, see if we're here. I want you guys to have quiet in this. No, you're using PQRST. And then, oh, yes, so you could use things like amplitude, wavelength, and frequency. Yeah, so like wave, when it says wave, is it PQRST?
We're 10 people in, right?
yes. Great. Why are you reading out loud?
Because when I understand something, when I read it in my head, I gotta read it out loud because I'm thinking I'm reading wrong.
Hey, sit over here on the side in one of those open desks. No, use the notes that we took today. Yeah.
Okay.
Just bring it here. I don't want number 9 says. Yeah. One wave every 8 seconds. Alexa, how about just like you? Sacramento, what are you asking for? Huh? There's a textbook down there on the bottom shelf if you need some notes. Hell, you do anything, you're sitting back there munching on your McDonald's. Okay.
What you tell us to do from the 17?
I said just draw on the wave with the pencil and pen. Draw a wavelength. You don't actually have to measure it. Stop. Because if she answers you, I'm going to give her a 0 too.
Period.
Hmm?
From period.
Here's a formula. 1 over the what?
Yeah, you got a question? Yeah, project? Try working instead of turning in stuff back blank. Well, so this way, and then you move it up and down. Yeah, horizontal this way, and then you move it up and down. Look this way, and you're moving it up and down. Does that go up and down? Show me a longitudinal wave on my paper. Is that longitudinal? Or transverse?
What you just saying about?
So does that go up and down? Then that's. Because if you were done, I should not hear preserve. Mr. East Tush.
still working, have about 4 minutes. The school bells have sort of speeded up. I think they're reading about 119 now. Oh, get it fixed.
I mean, it's working like Edison. He said it could actually begin.
Okay.
He said it might have happened with the battery, like, the internal battery, like, got messed up, but like, I don't know, somehow, like, I guess in the boot thing.
It got it back? Okay, sounds great. So I see Sierra still working. Is there anybody besides Sierra still working? I took my calculator. Y'all stop borrowing mine and sticking it in the tub. Alexis. That says Ms. Walls. Ms. Walls, stop borrowing mine and putting it in the tub.
The first time I ever did.
It is not the first time I fetched my calculator out of the tub.